The next important principle of object-oriented programming is going to be the idea of inheritance. Now, inheritance is a very nice feature that's going to allow you to save some time and effort and not force you to duplicate a lot of code. Now, the basic concept behind inheritance is that I can create a hierarchy of classes that can inherit functionality from each other and then ultimately save ourselves from doing a lot of that duplicate code. So a very common example when you're working with inheritance is the idea of creating some sort of structure or series of classes that are going to model the workforce for a company. So let's say we're going to have managers, we're going to have employees, and we're also going to have some commonality or some common functionality between the two. So let's start off by seeing how we would model this type of thing very simply within Swift. Well, at the end of the day, an employee and a manager share certain characteristics because they are people at the end of the day. So let's create a class to begin with called person. Now, because we are starting to introduce the concept of inheritance, you are now restricted to the use of classes. Structures do not support inheritance because of their nature and their data type. So you're going to need to use classes in order to follow along for the rest of this concept for inheritance. Now we're going to create a person and we're going to give it some properties. We'll say that this person has a first name that's going to be a string and that it's also going to have a last name that's a string. Now at this point, it bears noting that I can absolutely define properties this way. If I do define them this way but don't initialize them, then I have to provide an initialization method that's going to handle that for me. And that's exactly what this little red dot is telling me right here. It doesn't have any initializers. So I could either just default these properties to be empty strings, or I can provide an initializer. But for illustrative purposes, I'm going to provide an initializer, and it's going to become very interesting, and you'll see why very shortly. So I'm going to provide two inputs to this, an F name and an L name, which are going to be strings, which are ultimately going to be used to initialize first name as well as last name. So there you go. Now we have a class person that represents a normal everyday person that has a first name and a last name. Now the next rung on the hierarchy is going to be the concept of an employee. So let's create another class that's going to model the employee, and this person is going to have maybe a job function, which is also going to be a string for simplicity's sake. And for this case, we're just going to initialize this to be something else. So we're just going to say this person is going to be a developer. And then obviously this person can also, or this employee is going to have some function to do within their job. So we can create a method here and we'll call this do work. And you can make this as complicated or as simple as possible. But in this case, we're going to simply return a string just so we know that this person's actually doing something. And we're going to return, I'm doing my work. There you go. So now we have two classes, an employee and a person, that represent some functionality that's existent in the real world. Well, now I can go ahead and I can come in and I can create a new employee. So we'll say employee 1 is going to be an employee, and then this employee, I can access the job function as well as the do work method here. So I'll go ahead and do that, and you can see this person is doing their work. So that's very nice, but what happens if I need to access for this employee their first name and last name, maybe for payroll or for tax purposes or whatever have you? I don't want to have to copy this information and then duplicate it in here, because then I have to maintain even more code. So the way around that is to use inheritance. So to do that, I'm merely going to come up to my employee class declaration here, and I'm going to, just like I did for protocols, I'm going to specify a colon, and then I'm going to define this as being a person. Now, this is going to cause a little bit of a breakage here, and I'll show you why in a minute, but the nice thing about this is by simply adding this on the tail end of your declaration of your class, you now get access to the functionality that is found within person. But with that, you're going to change some of your implementation. So as you can see here, I got an error here because I'm missing arguments, or missing an argument for parameter fname in my call. So what happened now, because I inherited person from employee, if I were to look at the initializer here, I now get the initializer that was defined within this person class. So that's kind of nice. So now I can specify the first name as being Derek, and I'll specify the last name as being Jensen. Now, if I were to come down and dig deeper into this employee object as employee 1, not only do I have the do work method and the job function, I also now have a first name and a last name, so I can get access to all of those things that were exposed to me in this person class. So I can take a look at first name. I can also come into employee 1 and take a look at last name. So now I have this concept of inheritance where I'm inheriting the person functionality in employee. Well, let's say we keep going. Let's say we have a manager, so we'll create a manager class. And a manager is also going to be an employee. So I could say that this is going to be a person, and then I could add on all the functionality over and above from person, but really a manager is still going to have a job function just like an employee does, and a manager is going to have to do work. So now I can create multiple levels of inheritance where I can have manager inherit from employee who inherits from person. So I can create this very large hierarchy of objects that are going to allow me to share all that functionality across the way. So now let's say that a manager is actually going to have employees or maybe direct reports. We'll say direct reports. And that's actually going to be an array of employee. And the way that we're going to define an array of employee is going to be using this shorthand notation of square brackets and the type of the objects within the array. And we're going to talk about arrays a little bit more in an upcoming lesson, but just take my word for it at this point. And then we'll just initialize it to be an empty array just to get past the little error there that was saying that I'm going to have to use an initializer. So now I have this concept of classes and inheritance that's going to allow me to save myself a lot of duplication. So now I can create a new instance of a manager. We'll say manager 1 is going to be equal to a manager. And as you'll see here, I'm also inheriting from the initializer that's 2 levels deep. So now I can come in here and say John Doe, like that. And I can look at manager 1, and I can see that I have a job function, I have first name and last name, I can do work, and I also have a series of direct reports. So I could come into direct reports, and since this is an array, I have access to an append method, and I can add in here that employee 1 is actually going to be a direct report of manager. And now I have the concept of a manager having direct reports, and one of the direct reports is actually employee 1 that I've defined up here as being myself. So as you can see, I can start to create these very rich hierarchies of objects and be able to restrict the amount of duplication that I'm creating within my code, and at the same time create some very nice feature-rich classes to use within my application.